In this video, we'll be looking at simplifying radicals. First thing to understand about radicals is that little thing that goes around it. The square root sign is what we call the radical sign. The number that's inside of the radical sign is called the radicand. Okay, so the sign is the radical sign, and the number is the radicand. So the square root of 16, that means what number can you square to get 16? Well, of course it's 4, because 4 squared is 16. Here's a list of perfect squares. You really should memorize these because when the radicand is a perfect square, we get a whole number answer. For example, the square root of 36, that would just give me 6. So you should memorize that all of these numbers squared equal to these other numbers, and that the square root goes back. So for example, you should know that 11 squared equals 121, and that the square root of 121 equals 11. You should know how to go both ways, at least up to 12. You have to have that memorized because you need to be able to recognize them quickly. So for example, square root of 49, 7, square root of 25, 5, square root of 121 is just 11. Alright, now the radicand is not always going to be a perfect square. When it's not a perfect square, for example 36, 49, 64, then we can simplify the radical or use your calculator. Well, most of the time we're not going to use our calculator, so we're going to have to learn how to simplify the radical. So we're going to pull out factors of the number. So I don't actually want to start with 720 here. I want to start with a slightly smaller number so we can look at the process that we take when we go through that. So let's look at 28. Square root of 28. If you type that in your calculator, you get a decimal. And we don't want decimal answers here. We want whole, well, not whole number answers, but we don't want any decimals. So the way that we break this down is we look for a perfect square that goes into 28. So my perfect squares, if you remember, are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. So you got to ask yourself here, which of these numbers divides evenly into 28? Well, obviously it won't be anything from 25 up. 16 doesn't, 9 doesn't, but 4 does. So 4 goes into 28 7 times. So once you know that 4 goes into 28 7 times, I like to circle my perfect square, which is 4. Now, this really means the square root of 4 times 7 now. Now, what is the square root of 4? Well, it's just 2. So you put a 2 on the outside and a 7 stays on the inside. And that's actually your answer right there. So now let's look at 720. Let's find a perfect square that goes into it. Well, looking down my list, very easily I can see that 36 goes into it, and that's going to be 36 times 20. Now 36 is a perfect square. So on the outside I'm going to have a 6. And on the inside I'm going to have a square root of 20. But you're not done, because to be done with the inside, you have to have no more perfect squares that go into it. For example, over here, 7, there's no perfect square that divides into 7. But for 20, a 4 goes into 20. So 4 times 5, and 4 is also a perfect square. So we can pull out a 4 actually. So it's going to become 6 times 2 square root 5, which is 12 square root 5. Now, there was actually a bigger perfect square that went into 720. And if you'd seen it, we're only taking you one step, and that is 144 times 5. And that is going to become 12 square root 5. Alright, so that's what we just did. Now I want you to pause the video and practice these three out to simplify them. Alright, let's see what we can do. So a biggest perfect square that goes into 75 is going to be 25 and 3. Now you might have been tempted to say 15 and 5, and there's a way to do it there, but not with a perfect square, so it takes longer. Now 25 is a perfect square, so 5 comes out and 3 stays inside. For 45, the biggest perfect square that goes into 45 is 9 and times 5. So that's the perfect square. The square root of 9 is 3, square root 5. And finally here, 100 is the biggest perfect square. Square root of 100 is 10, square root 2. If you notice on 3, 5, and 2, there is no perfect square that goes into those. Now, really quickly, I'll show you another method that takes longer, but it might be easier for you to see. Let's say on 75 you've done 5 and 15. Well, you can still break 15 down to 5 and 3. This is where we just make factor trees all the way down. You have a pair of 5s, a single 3, so a pair of 1 5 comes out and a 3 stays inside. Same thing. Now, sometimes there's a number on the outside already. This is very simple. Don't freak out or get confused. All we do is multiply this number by whatever we bring out. For example, biggest perfect square for 18 is 9, so 9 times 2. So I already have a 5. Now I'm going to bring a 3 out. So 5 times 3 is 15, square root 2. Same thing here. Biggest perfect square for 150, 25 and 6 there. 25 is perfect, so 2 times 5, square root 6 is 10, square root 6. And last here, we can multiply radicals. To multiply radicals, you do the outside number times the outside number, the inside number times the inside number, and then simplify. So 6 times 1, if we don't have a number written there, it's 1, is 6. 3 times 6 is 18. Biggest perfect square for 18, 9, so 9 times 2. So 6 times, we're going to pull out a 3, so 18 square root 2. Pause the video and try these two out. All right, let's see how you did. So 5 times 1 is 5. 2 times 6 is 12. Biggest perfect square is 4. So 4 and 3, so we can pull out a 2. So 5 times 2, square root 3, gives you 10, square root 3. Finally here, 12 times 4 is 48. 8 times 3 is 24. Biggest perfect square for 24 is 4, so 4 and 6. A 2 is coming out, so 48 times 2, square root 6, is 96 square root 6. So please make sure you get the homework done, and thank you for watching.